Okay, I'm going to continue with this problem. I got interrupted a long time ago, and so I'm not even sure where I'm at. So let's go ahead and continue. So working this out, I would get 2,000 and this would be a negative 10,000 plus b. So we'll add 10,000 to both sides. I would get 12,000 is equal to b. So the equation would be y equals the slope of minus 1,250, that was the slope, times x plus 12,000. All right, then the next part, it says find the value of the copier after 15 years. So we are going to, that was the first answer. We're going to plug 15 in for x, so I will get y is equal to 1,250 times 15 plus 12,000. Actually, this value of 15 isn't any good because with the depreciation that it has, this copier is going to go all the way down to 0. So I don't want the problem like that. This is a bad number. Let's pick something like 5.5 years. So we'll say what's the value after 5.5 years. So what we'll do is we'll stick 5.5 in for x. Now let's work that out. So it's going to be y is equal to a negative 6,875 plus 12,000, because a negative 1,250 times 5.5 gives me a negative 6,875. So let's add that together. And so I'm going to get the value of the copier after 5.5 years would be $5,125. Okay, the next problem is going to be redoing this regression. Now what we're going to have to do is use a graphing calculator for this. And what we're going to do is we're going to enter in the x values into the calculator list, enter the y values into the calculator list, and then let the calculator come up with the regression equation. We would find r from that also. Then we need to figure out what, given our equation, what would the y value be if we use an x value of 40. So to do this, I'm going to use my graphing calculator that's already on my system here. So I'm going to pull that up. And what we can see is that we can't see anything at the moment. Okay, I finally got the little calculator to come on. So what I do is I entered in the x values into my list. Now how I got there is you would go to Stat, and then you would make sure that the cursor is on Edit and Edit. And if you press Enter, that takes you to your spreadsheet. And then you want to enter the x values into L1 and the y values into L2. And so I already did that. So now that I have my values entered in, I'm ready to let it figure out the regression for me. To figure out the regression, I'm going to press Stat, and then I'm going to go do a calculation. So I'm going to go to Calculate. Then we will go down to number 4, the linear regression. Okay, now depending on the software you may have, it may have a list that says what column do you want to do your linear regression on, and it may say L1, L2, and then something like store the regression. So you should have L1 being your X values, L2 being your Y values, and then you're going to go down to the calculate portion. For these older software, you're just going to press enter. The linear regression will automatically place L1, the L1 column for X, and L2 column for Y. So let's go ahead and press enter. And it gave me my values here. So what we see, we got y equals ax plus b. That's the equation of the line where a would be the slope and b is the y-intercept. So we can go ahead and write down the equation of the line. Okay, so the equation of the line would be y is equal to 3.05x plus 63.5. The next thing I need is the correlation coefficient. That's the R value. R is equal to 0.98. And a good correlation would be like a number above 0.9 or negative 0.9. Remember, the correlations go from between a negative 1 to 1, with the closer I get to 1 or negative 1 being a good correlation. And the last thing I have to do is figure out what the value of that equation is going to be when the humerus is 40 centimeters long. So let's go ahead and enter that. I'm going to get to a different screen. And here's my equation, so let's go ahead and enter 40 in for that. So 3.05 times x value of 40 plus 63.5. That gave me that when I entered in y is equal to 3.05 times 40 plus 63.5, I get the value of 185.5 centimeters. Okay, the last problem I'm going to do is a word problem with 3 equations and 3 unknowns. Unlike the problem that we have up here in the practice worksheet, we decided this was going to be a little bit too complicated, so this kind of a problem will not be on the test. So I'm going to replace it with the word problem that's down here. And I think I already mentioned is that we're not going to have problems where you actually have to plot the whole scatter plot by itself, because that would take too much time for the test. So this kind of a problem also will not be on the test. You'll be using your calculator to do the regression. Okay, so let's go ahead and work this. And the first thing I need to do is write 3 equations for this. So I need to define the variables. So I'm going to use R for the cost of the roses. I'm going to use C for the cost of the carnations. And I'm going to use T for the cost of the tulips. Let's write the 3 equations. 3 roses plus 2 carnations and 1 tulip is equal to $14. 6 roses plus 2 carnations plus 6 tulips is 38. Okay, let's get back to this. Had another little interruption. So anyway, Our third equation is going to be 1 rose, 12 carnations, and 1 tulip cost $18. So there are my three equations. Now let's decide what variable I'm going to eliminate. It looks to me like if I try to get rid of the t's, that's going to be the best. So that's what I'm going to do. So we notice that the first equation here and the third equation, they both have a t, so why don't we just take the first equation and multiply it by a -1. And that'll get us to allow us to get rid of the t, so let's go ahead and do that. So if I multiply the first equation by a -1, so this is the first and third equation, I'm going to get a -3r minus 2c minus t is equal to a -14. The other one will be r plus 12c plus t is equal to 18. Let's add those together. I get a -2r plus 10c is equal to 4. All right? Let's dig up another set of equations, and I am going to have to deal with this 6 now. So let's take and multiply the first, let's do the last equation. Let's take the last equation and multiply it by -6. So let's do that. So let's do the -6 on this equation. And what that would give me is a -6r So -6 times 12 would be a -72c, and then I would have a -6t. I picked the wrong one. And that would be, so where am I at? I got a -6r minus 72c minus 6t is equal to a -108. And we were going to combine that with the second equation. Okay, continuing. 6r plus 2c plus 6t is equal to 38. So let's add those two together. The r's are going to cancel out. I'll have a -70c is equal to a -70 dividing by -70. I've got c is equal to 1. So actually in this one I got kind of lucky. Normally this shouldn't be this easy. You would, depending on what I would have picked, I may not have had the r's drop out, and I would have another equation which I would combine with this one. The way it works out is I can just back substitute already. So if I take c equal to 1, All right, let's continue. Anyway, so I've got, let's put C equal to 1 in here. So I've got a minus 2R plus 10 times C, which is 10, is equal to 4. Subtract 10 from both sides, I get a negative 2R is equal to a negative 6. So R would be equal to 3. So I found C, I found R, right? So C we said was 1 carnation, that'd be up here. R is 3. So let's substitute those two into one of my original equations. Let's just do the one here that's R plus 12C. So if I put R into there, that would be 3 plus 12C. That would be 12 times 1 plus T is equal to 18. 15 plus T equals to 18. So I would get T is equal to 3. All right, so here is my values. The cost of the roses would be $3. The cost of the carnations would be $1. And the cost of the tulip would be $3. And I think that's finally the last of the problems. This has been a rough video with all the interruptions and everything, so hope it helps.